Okay, so hi and welcome to this session about updates that we've been working with since previous Connect. So this can be seen as some kind of lightning talks where we have small presentation by a couple of different people here. So yeah, we have Igor here who has been working with libAVB and a little bit related to U-boot and also some keymaster things. We have Jens who has been working with also U-boot features with TEEs in this case. Jerome will let you know a little bit more about a way that you can use dynamically linked share libraries from secure side. And V has been working with Keymaster also. And then I will kind of pick some more minor things also that we mentioned. But we start with you, Jerome.
Thank you, Joachim. So I have a couple of words to say about TEE dynamic link. So that's a new feature that was introduced in the latest version of OP-TEE. It's available in 3.2. So what it is, basically nothing really surprising for any of you, I suppose. Basically, you can create and sign a shared library using the usual linker command, so ld-shared, you provide a SO name, and then you produce a shared library instead of producing a static lib. And then we have our own, as usual, signing script that allows the binary to be signed for later being loaded by the OP-TEE OS core. Then the second step is obviously to use this library in a trusted application. So you will also use the linker, obviously, provide some object files, and then you specify the shared library as a link argument, and then it will produce a nice ELF file that you will then sign using the same script. So basically, instead of having only one binary, which is the TA, trusted application that you provide to the T, you have a couple of them. The main application and the shared library, exactly like in the normal world. So to facilitate or extend the way we are currently producing trusted application, we have added a couple of macros in our Makefile rules. So you just specify the name of your shared library like this, and you give a UID because everything is based on unique IDs in the T. And then you include the Makefile, and it will do everything for you, basically. And this is the same, the equivalent part in the TA Makefile. You give the binary name, and then you just specify that you need to link against the shared library. So you can see some example in our test suite. We have basically added one test that depends on the shared library on the secure side, so that's a kind of a regression test for us. Just a few words about the actual implementation. So that was really an extension of the current ELF loader that we have in the OP-TEE core. So what had to be done is to locate the PT dynamic entry in the program headers, then pass the DT needed entries. That's basically the list of the UIDs you need to run the TA. Then we load and verify each library. You should know that we do not share memory pages for the moment, so that's shared library that are really shared in the storage, but not really in memory, so no gain in memory for the moment. That could be modified later if needed. Then we have this relocation processing that occurs, so the on-plug dat, on-jump slot, and HTC4 dat, HTC4 jump slot relocation tags are processed, and this is the place where symbols are resolved across binaries, so we basically look at functions and link them properly, and then we branch to the entry point of the trusted application as always. Note also that all the tools that we have put in place to help debugging trusted application have been updated, so that the stack and winding crash code has been updated to show the different libraries, obviously. And we also have a Python script to help translate crash dumps to source code file lines. This has been updated also. So for instance, this is a nice crash of a trusted application. In this case, it is a panic dump, I think. So OP-TEE will show a lot of information. What's new with the shared library stuff is that we just identify the libraries with a number. So that's library number, binary number 0, binary number 1. You see this 0 is found here. There's the UID and the load address. And the 1 is also here with its UID and load address. So the first file is the main executable, and the other ones are the shared libraries. So if you decode that, yeah.
Where would you see that? Where would the output come out?
This output comes on the secure console when you're debugging your application. So if you have built OP-TEE with the default flags, then you will have this, this output. And here is the out this text through the symbolize script, then it will be able to decode the stack addresses, give you function names and source code. And here you can see that those two, this address falls into the library in a different path. So yeah, that's it. Any question, or maybe we keep question for the end? Yeah, no? Question? Yeah. Yeah.
So the shared libraries, I guess, as you load a TA, at the same time, you will kind of have some supplicant communication to load the shared libraries as well, and then perform the linking before finally the TA is up and ready to start executing.
Yes, exactly. Shared libraries are exactly loaded the same as the binary for the main application. So same process, they can be stored at the same places in the file system or in the early TA space, as we called it. So that's why also we chose to identify the library with the UUID, because it makes that compatible with the way we load the binary in the regular way.
Do you guys currently or in the future plan to support encryption of the object code or some part of the ELF file, so that basically attackers can't, try to figure out where things are to attack for certain vulnerabilities?
Yes, currently the trusted applications are signed, but they are not encrypted. But we do have an interface, so at the point the OP-TEE core will load the TA or any binary, there is an interface, and we currently have plugged only a signature algorithm, but it's a possibility you can change that code and possibly add some encryption to it. Yeah.
Actually, we do support encrypted TAs and shared libraries, but you have to install it in a certain way. But even as code is today, it's supported.
But I think what you're asking is from the first time, I mean, when you run it, if you support encrypted trust applications, that case. And that case is no for the moment. It's been discussed a couple of times whether we should do it or not. But if you install it, like Jens said, then you can run it from Secure Start directly. So you don't really do it anymore visibly for others.
Yep. Any more questions? No. Jens?
Hello, Jens Wicklander is my name. So I've been working with an OP-TEE driver for U-boot. We have one for the Linux kernel, which I also wrote some time ago. And yeah, it's has only been a matter of time before we have needed it in U-boot also. As in the Linux kernel, the focus is on OP-TEE based on non-trust zone. I'm working on the upstreaming right now. I'm at V3, and it's progressing well. I have good responses from Simon Glass, who helps a lot with the reviewing. I expect that after Connect, I will send out the V4, which will be even closer to getting acceptance. So if we look at the different parts of the driver, it's similar to the kernel model, but we can see that we have the normal world part. That's a bit simplified if we compare to the kernel, where we have, you see, we have a user space and a supplicant and all that stuff. And here it's much shorter flow, but on the other hand, it's a less complicated environment also. We don't have user space. Secure world is the same. We have the OP-TEE message protocol, and we use SMCs as a way of communicating. So the interface to OP-TEE, it's a new U class. That's how you abstract devices in U-boot. And the U class is similar to the TEE subsystem in the kernel. And in the class, we register the different drivers, in this case, the OP-TEE driver. And yeah, the trusted OS is, of course, running in secure world. And here we can see how it's organized in the Linux kernel. We have user space where the client is, and here we have an additional interface, which is the kernel interface. And also we have the TEE supplicant, which is a daemon running in user space. In U-boot, it's integrated within the driver. It makes it both easier and harder in certain ways. And yes. And then the actual OP-TEE driver in U-boot, we can see that we need to be able to serve OP-TEE in the same way as in the Linux. We have to be able to handle RPCs. Here it's primarily to do file system access in RPMB, since in U-boot it's a single-threaded environment, so we don't have mutexes or anything like that that will require assistance from normal world. And in order to access RPMB, we use the MMC driver in U-boot in a similar way as we do it in Linux. This way we can avoid having an MMC driver in OP-TEE, and also we avoid the problem of synchronization between different drivers. And this way of routing RPMB frames to the MMC driver, it's quite straightforward. It's only one new function that I had to add in the MMC driver. Yeah. And then we have the client interface, which is basically the U-class interface in U-boot. It's as you can basically build a TEE client API on top of this. Actually, we have it for testing purposes, but it's probably not going to be upstreamed, since it doesn't really make any sense to have there. All the code that you have in U-boot will probably be just for U-boot and nothing else. The most important functions are find device in order to get a handle to communicate via, and then we have the usual open session, invoke function, and close session. That's it.
You don't load the TAs from your code, so they have to be compiled in or something.
True.
That's how it works. So you don't load the TAs into...
Yeah, that's right. We don't have support for loading the TAs from file system, since then we would need support for that in U-boot also, and it's unnecessarily complicated right now. Instead, we have a facility called early TA, in which the TA itself is compiled into OP-TEE, and we'll load it. So it's just a part of the OP-TEE binary.
It's there when you start it up in an earlier boot stage.
Exactly, and that's also an advantage in other ways, because then you have early access without having a supplicant or anything.
Makes perfect sense.
Yeah.
Sahan? Yes, it is. Can you say anything about, or we're going to say later about this our replay protection, memory block frame things? You talked about RPBM frames. What are them? How do you guys use them in your system? What's the security issues there?
We use RPMB in the same way as when Linux kernel is up and running. Secure World is responsible for creating the frames, and the frames contains HMAC sum, which is using a shared secret with the actual eMMC, and it has to match in order for the eMMC to accept the frame, and vice versa. When we get the response, we check that the HMAC is correct.
But I'm more asking, what are you using that region for? What kind of access, what are you putting into it? You're not putting a file system there, so what kind of accesses, what kind of storage are you using it for?
We store secure storage objects. It's objects that the TA itself can create, and the interface for these objects, it's part of the TEE internal API.
Yeah, but the only thing is that region is not that big, so you can only limit the amount of secure storage.
It's a bit limited, but on the other hand, I mean, what would you like to store in this stage? It's probably anti-rollback counters and stuff, and that takes almost no place.
But not like TLS server certificates or something like that. That could
you
be
could
huge.
have a certificate or something.
But not like for a whole big website with lots of...
No, but on the other hand, you don't need that during U-boot, for instance.
The leading use case for this particular work here in U-boot was what Igor is going to present now with libAVB, for example, since you need to store some state variables and boot stages and so on. So that's a very limited area of the total storage that we're using for that. So, but yeah.
Yep.
Are there any restrictions on how memory is shared between U-boot driver and OP-TEE at this stage, or is it just like how it works during runtime with Linux?
It's exactly as while Linux kernel is running. Yeah.
Right. So you can have both registered memory as well as temporary references.
Actually, we have simplified it a bit. We have only memory that you register from U-boot.
Right.
So we don't use this pre-allocated pool.
Right.
And that's just because we didn't need both.
Okay, thanks.
Okay, thank you. No further questions? Yep. So I'll leave over to Igor.
Thanks, Jens. So my name is Igor. I've been working since Connect in Hong Kong on Android verified boot support, version 2 support in U-boot. Sorry. Yep. So just a little introduction and summary what is going on. So what is Android verified boot? So just in 2 words, it establishes a chain of trust from the bootloader to system image. It kind of provides integrity checking of kind of boot image with Linux kernel and RAM disk, and also integrity of system vendor partitions. So kind of it just verifies root hashes of DM variety hash trees. AVB2 support was added and finally kind of upstreamed. So it was included in U-boot version 2018.7 release. It was a mistake that it didn't include the full link, but you can download this presentation. Just click on it. During last Connect, there was a kind of big presentation about kind of overall of all components of Android verified boot and how to enable it on a particular board, and about Android verified boot subset of commands in U-boot, and yep, that's it. So just 3 kind of major kconfig symbols. So basically we have introduced 3 kconfig symbols which enables subset of commands for invoking this verification chain. It's config cmd avb. Also avb verifies kind of component. It's in common directory. So there is a avb verify C file which provides implementation of avb operations. So it's kind of proxies to particular MMC operations in MMC subsystem in U-boot, and libavb. So libavb, it's kind of vanilla libavb snapshot from AOSP. So I've introduced a minimal amount of changes. So we had a kind of a big discussion if we really need to follow the coding style, or we should kind of change this library and to follow kernel coding style, just to conform to kernel coding style. But finally, it was included as it is, just to simplify the process of fetching updates from AOSP project. Currently, this AVB verifications is invoked from U-boot shell. So you basically there is a sequence of commands, yeah, to boot, for example, from MMC to RAM Android boot image, and then actually boot m command, for example, consumes this Android boot image by and then it checks by magic symbols that it's Android boot image. That's why, as there is no kind of standalone command to boot Android, that's why we introduced kind of a dedicated command to provide this verification capabilities. So you can just integrate it into your kind of U-boot environment. So all details are in this README file, how it can be done, and there is a particular example of how it's done on Texas Instruments AM57 board. Also, this is an example of use case based on this OP-TEE client that Jens introduced in U-boot. So basically, there is a recommendation, like I said, or maybe it could be mandatory in future, but these AVB operations related to storing rollback indexes and device state, and also maybe 2 months ago there were introduced 2 additional AVB ops operations called write persistent value and read persistent value. So there is recommendations that tamper-evident storage should be used, and we decided to leverage OP-TEE and secure storage API in OP-TEE and use RPMB as a kind of backend. So basically how it works. As Jens already explained, there is RPMB file system components. So it's it's a backend for secure storage component. It generates RPMB frames, and then all these RPMB frames are routed back to normal vault and is consumed by SMC system. RPMB key is obviously it's stored and it's not revealed to normal vault, it's stored in secure vault. And there is a AVB trusted application which is compiled as early TA. So basically it's stored in additional section in ELF binary of TEE. So it's kind of additional ELF section. And each AVB operation leverages TEE U-class driver. So we communicate with AVB trust application, and AVB trust application uses secure storage API to store particular value. And what next steps are planned? So currently I'm doing just a bunch of refactoring because as it was initial implementation, it does have a lot of issues. So we still need to implement some additional AVB ops. For example, this public key, which is used for verification of VB meta image. This is initial image where all kind of crypto detail which are used for verification of further partitions. So it consists of these details. We need also to verify this VB meta partition, and currently the public key, RSA public key, is hard-coded. So we should use also, for example, Tamper-evident storage, in this case, AVB-TA. And there is no implementation for write persistent value and read persistent value, as these two functions were introduced just a couple of months ago. Also, I faced an issue on Poplar board. So it relates to the probe order in U-boot and Linux. So basically, there is no synchronization. So for example, in Linux kernel, I faced an issue when SD controller was enumerated as 0 and eMMC as 1, but in U-boot, it's vice versa. So basically, and the problem is that the ID of eMMC controller is currently hard-coded in OP-TEE AOSP core. So we should decide normal word part which ID to use. Also, there is a kind of the major feature. It's AB support. It's kind of a half-ware copy of all partitions, and this feature is needed for seamless updates, so we can kind of have 2 copies of partitions. Yeah. And also fastboot integrations, I guess it's more for debugging purposes and to provide the kind of final user kind of ability to unlock his device. So it's a kind of subset. Maybe you've seen already kind of OEM lock unlock commands. Yep, I guess that's it. Good.
Your picture there with the RPMB, I can never get the acronym. It wasn't clear, that one, for the eMMC controller, it's going to normally be run at runtime. It's going to be controlled by the Linux eMMC driver. So how is the U-boot going to access RPMB frames? Is it going to send it through Linux to the Linux driver, or how are you doing it? Or is it that this U-boot access is only happening at boot time, and that's, but then what happens if I want to do secure, I want to add something into secure storage at runtime after booting? Can how does that work if I can't, for U-boot, because it's not going to be able to access the eMMC controller simultaneously?
The file system we have in RPMB, it's only OP-TEE that uses that. So And it's like, it's just blocks inside the RPMB, and it's the same if we do it via U-boot or the Linux kernel.
Yeah, but I mean, how do you synchronize the two people accessing? Because once Linux starts accessing the eMMC controller, if you try to do anything to that eMMC, you're going to bump into its, you know, the controller can only really work with one person at a time.
Yeah, but when the kernel is up and running, U-boot is no more.
Okay, so yeah, so you're basically saying that there is no case where U-boot would never want to do things once Linux is running, so it's mutually exclusive that way. There's no case where you would allow a U-boot variable to be set or secure storage set through the U-boot thing. That's all going to be done before Linux starts up.
Yeah, right, so, yeah.
Thanks. Jens. Other questions? Okay, thank you.
Hi. So, sorry about the title there. It should be OP-TEE on HiKey AOSP. So we had a session previously about the OP-TEE AOSP integration during the Hong Kong Connect about 6 months ago. Since then, we've had some improvements. We've set up a daily CI build to test for any build errors. We've upgraded our default build to Pi, which is fully treble-ized. And we've added some build scripts to simplify the process of repo syncing and building. And with the scripts, we get free upgrades, I should say, because previously, if we upgrade to a new release, we have to excuse me, repo init again the new manifest file. But with this, it actually reads the manifest file that needs to be built from a Linaro repository. So you basically run the script and it will sync to the latest manifest file for that version. So to try it, you just what's the laser pointer? Top one. Right, sorry. Right. So to try it, you just clone this repository OP-TEE Android manifest using this branch, and then just cd into the directory and just run this sync-p and build-p script. This is a lot more simpler than the previous commands where you have to do repo init, repo sync, run a bunch of script patch script files, and then run the make command. This is all automated for you. You have the option for to build a relatively stable build with pin manifest. Technically, you can this -v is like for version. So technically, O and master builds are supported, but since we mainly use P as the default right now, O and master might bit rot a little bit. So I mean, if you try it and you get any errors, please report back to us. So here I'm just showing you that this is currently the list of pin manifests that we have. This is sort of random as we are going through builds daily, and we have a stable build. We just upload a manifest file to test. So there's not really a structured release procedure at this point. And then once you're done building, just the default steps, you copy the images to the installer folder, run, and then you run the flash all script. Before that, you have to put the board into a recovery mode. You can put it into UEFI fast boot mode, but at least in our experience, it's just easier and more stable to flash everything in recovery mode. Then power off the board, take it out of recovery mode and power it back on. And then just adb root and run the xtest command. That's it. Any questions?
So I'm not Etienne, but he's not here this week, so I'm trying to cover for him. PK611 work with OP-TEE. So we started out thinking about this last year, and Etienne, he have been doing quite a lot of work with it, and he had a quite long session about it in Hong Kong. So if you want to know more details, please go back and look at that session. We had to restructure the TA interface a little bit since, well, if you look at the license in the PK611 interface, you can see that it's GPL. So we can't just use it right off. We have to do something similar, invented by ourselves. So this is what we have been working with also now with the refactoring here. But what you can find in the current, well, you can see there are links to open pull requests here also. What you can find working there is AES operations, so you can use the normal things like encryption with ECB, CBC, and CTR, and so on. There is also support for RSA generation, verification with keys, similar with elliptic curves. That's there. I don't have that much more to say about this, but the main development branch for his what we call secure key services is what you can find on Etienne's branch here. But the pull requests here are intended to be merged sooner, I mean, at some point in time. So they could be seen as this is probably what it's going to look like. But we have seen interest from other people also outside Inaro. There is one guy from, I think it's a university, who are currently working with this. So we have a couple of other people who have been active on giving feedback and developing features here. So any questions related to PK611? All right. This is the rest of the stuff, a little bit scattered, things we have been working with also. So what you have heard about now are kind of the main features, the bigger features that we've looked into. But there are a few minor things that could be worth mentioning also. Recently we are starting to discuss Fossology, scan code tool, and so on. We started to tag all our source code files with SPDX half a year ago, maybe a little bit more than that. So we have had the kind of the groundwork done, but now we also need to gather it in a more readable way that other people can use. So that is where the Fossology and scan code comes to play. We are still working with this. I mean, this is ongoing work, all of the Fossology. We have a session tomorrow, I think it's tomorrow, about this, where we are going to discuss what do vendors and OEMs, what do they actually want to have from this? Because we think we have all the tools that we need now, but now we need to get the requirements. How are you using it? I mean, when you are reading the licenses and such. Build route for OP-TEE, developer support. So initially, many of you know that we had a very stripped down root file system just based on BusyBox, kind of hard-coded what kind of files we were using and so on. And we decided to upgrade it a little bit now. So we have been using build root now since a couple of months back, and that is working for all our supported platforms. And that made life a little bit easier for us since we can easily enable developer tools, Valgrind, strace, and in your case, Jens, it was you started doing this because you needed OpenSSL, for example. So it's made life a little bit easier for us. We had to pay a little bit in build time and downloads and such, but in the end, we think it's worth it. The third thing here, embed TLS for TAs, that initially came out of in the key master work we have been doing. We had some need to do X509 certificate handling. And we had the option of doing it using a service in the core itself, or we could do it in user space in the TA directly. So we decided to do it in user space here. Don't confuse this with ongoing work that we have with replacing libtomcrypt with embed TLS. That's a separate thing. But this enables you to use embed TLS from a trusted application point of view. Spectrum meltdown, we, beginning of the year when everything happened, we've made most of the fixes, but later on we got some pointers from ARM saying that in some of the cases it was not sufficient what we had done. So we have fixed that for AR64 here in this case. It's about the branch predictor. Automatic testing, this is my pet project. So we have the ability now to test all the pull requests automatically on a HiKey device. We have had a few ways of testing before. We have leveraged Travis, we have leveraged Shippable, and we still do. I mean, we have, depend on what kind of test we're running and so on. And so we run QEMU using these automated services. We run some check patch and so on. But I did this since, well, Lava basically didn't fit for what we needed here. We had some special use cases to do things, but that's up and running now. GCC version, yeah, we just stepped it up. I mean, we knew that version 8 was coming, but some people were ahead of us and started to report some problems when they were compiling it and running it. So Jerome, he fixed a couple of issues, and we merged the patches last week, I think it was. So now it's working with GCC 8 also. Igor, you enabled a Poplar board using build.git. So for you who doesn't know, build.git is our way of making it easy for people to set up an OP-TEE environment on a certain device. Raspberry Pi 3, we get quite a lot of questions related to Raspberry Pi 3, so we use it from time to time in our team also, but it's not the go-to device, I would say. But since there are questions out there, and it seems to be, for natural reasons, quite easy to get access to a board, we think it's worth trying to keep it up to date at least. Igor, together with an engineer from ARM, they have recently changed the old way of booting to now do a more proper boot setup where you have ARM trusted firmware running first and then hand over to U-boot, kernel, etc. I mean, the previous way we used to do it was a real nasty hack, more or less. So this is pretty good. The only downside here is that we can't really easily update or running TFTPD, for example, to update the FIP that we could do before this. So, but in the end, this is better, I would say. And the final thing here, answering questions at GitHub, and this is what kernel guys, for example, do, talk using email. That's the same thing we're doing here. I mean, we get questions and so on. But I think it's fair to say that OP-TEE has started to become quite popular. So we have noticed that also in the amount of questions and people are asking and so on. So we spent quite a bit amount of time on the last one here also. So I think it's definitely worth to mention that here. So that's it. Questions? All right. Thanks for all of us.